In this video, we're going to look at some different ways to write exponential models from word problems, from equations, and from tables of values. So we need to be familiar with two different equations here. The first is this typical equation that we're used to, y equals ab to the x when we're talking about an exponential function. So a represents my initial population or my initial amount. So if I'm dealing with a word problem, then it would be the given initial amount. If I'm looking at a graph, it's going to be my y-intercept. If I'm looking at a table, it's the value that happens when x equals 0. B is going to be your growth or decay factor. Here you have to be a little bit careful. When you're dealing with growth, you always want to do 1 plus your percent of increase because you're maintaining all of the stuff that you have to begin with, so 100% of it, plus you're adding more. When you're looking at your decay factor, your B value is going to be the percent remaining in decimal form, and that really takes some looking at the specific wording of the problem. So we'll look at a couple examples with that. X is going to represent your time situation, and then Y is going to be the population at that given time. Another equation that we will see is this second one over here, which is y equals a times m to the x over t. And this is the equation that we're going to use when we are given a situation where we're talking about a time factor, so a doubling time or a half-life or a tripling time or something like that. Typically you're going to see double time and half-life most frequently. Similarly, a is your initial population or your initial amount. M is going to be your change factor, so for half-life it's going to be half, for double time it's going to be 2, if it's triple time it's going to be 3. X is going to be your amount of time. T is going to be your change factor time, so the half-life or the doubling time, however they give that to you. So your half-life time, your double time, your doubling time, and then again Y is going to be your population at any given time X. All right, so let's look at a couple examples here. So we're going to find an exponential function with the initial value of 12 and is changing in each of these given situations. So my initial value is 12, so remember this tells me a equals 12, so a is going to be 12 for all of them. So remember both of these equations back here have an a in them as your initial population or your initial amount. So if I'm increasing at a rate of 8%, so they tell me the percent of change, so I'm going to use that equation y equals ab to the x. And then my B is going to be, since I'm increasing, 1 plus, and then my percent in decimal form, so 1.08. So then we're going to go y equals, remember my A is 12, so 12 times 1 plus, or 1.08 to the x power. And that would be my exponential model for that situation. So over here, this one says we have a half-life of 10 days. So since I'm given that change factor time, we're going to use that second equation, a times m to the x over t power. So remember my a is 12. Since I'm talking half-life here, m is going to be 1/2, and then my half-life time is 10, so that's going to be my t. So here we're going to go a equals 12 times 1/2 to the x over 10. In question C here, we're decreasing at a rate of 15%. So this is where we have to be really careful. When we're doing a situation that is decreasing, since they gave us the percent of change, we're going to use this y equals ab to the x. So we have to be careful with B. B has to be the percent remaining. So if I'm decreasing at a rate of 15%, I'm losing 15%, which means I'm keeping 85%. So I'm going to use 0.85. So then I'm going to go y equals, again, my a value is 12, 12 times 0.85 to the x. D says we have a doubling time of 2 years. So again, since they told us that time factor change, we're going to use that second equation, y equals a times m to the x over t. So since we're doubling, m is going to be 2, and my time is also 2. So this is going to be y equals 12 times 2 to the x over 2. Tripling time of 50 hours, so again we're going to use that a times m to the x over t. So y equals 12. We're tripling, so m is going to be 3, and then x over my tripling time is 50, so t is 50. And finally, this one says we retain 90% of the population each day. So this, since they gave us the percent of change, we're going to use that a times b to the x. And in this case, they told us how much we're keeping, which is 90%. So my b is just going to be 0.9. And I'm going to get y equals 12 times 0.9 to the x. All right, in these examples, we're going to look at writing an exponential function from a table of values. So in this case, we know that it's exponential because they told us that in the problem. So we're going to use that y equals ab to the x. What I want to do when I'm looking at these tables of values is first try to find this row that's going to have an x value of 0. That's going to tell you your initial amount or your y-intercept, which we know is our a value. So in this case, we know a equals 4. Now we have a couple different ways that we can figure out the b value. You can just look at your table and try to figure out what multiplier I'm using to get from one x value to the next x value, as long as your x values over here are consecutive integers. So I'm going -2, -1, 0, 1, 2. So those are consecutive integers, so I can do that. So looking at this table of values, the fractions might be a little hard, but here you should be able to see 4 times 3 gives me 12. 12 times 3 gives me 36. So that tells me that I'm multiplying by 3 each time. So my b value equals 3. If you didn't see that right away, then you can kind of work algebraically here. So we would start with y equals, we know 4 is a, so 4 times b to the x, and then we can just choose any one of the other points in here. I'm going to choose this one because it looks easy. I'm going to plug this in for x and y. So 12 equals 4 times b to the first power. So then I'm going to get b equals 3 again. So we end up here with y equals 4 times 3 to the x. And then I know that this is exponential growth because my b value is bigger than 1. So this is a growth function. So we can work similarly over on this second example. So here I'm going to identify my initial amount. So I know a equals 8. Again, I can look at my table and try to figure out what I'm multiplying by each time. My numbers are getting smaller here, so I know that my multiplier is going to be a number that is less than 1. So you might look at that and think, oh, I'm dividing by 4, but remember, you need to think about that in terms of a multiplier. So to get from any term to the next term here, we're actually multiplying by 1/4. Again, if you didn't recognize that right away from the table of values, just work algebraically. So y equals 8 times b to the x, and then just pick any particular point in there that you want to. Let's use this one this time just to see how it works. So here I'm going to put this as 1/2 equals 8 times b squared. So we do have to do a little bit more over here because we have the exponent here. We just had the first power. So I'm going to divide both sides by 8, which will give me 1/16 equals b squared. And then we're going to square root both sides. So b would be plus or minus the square root of 1/16, which is going to be 1/4. Our exponential functions, remember, we were restricting b to be positive, so we know we're going to take the positive answer. So then we're going to go y equals 8 times 1/4 to the x. This time I know that since my b value is less than 1, that this would be a decay situation or a decreasing value. When you have a table of values like this, you can also use the calculator to find your exponential model. So I can come to my calculator and I'm going to put this data in my list like I would to do a linear regression or a quadratic regression. Clear out these values here. Put my new values in. I'm going to do this first example here. Once you have your values in, we're just going to go stat, calc, and just like we would for linear regression, or we did quadratic regression, cubic regression, quartic regression before, I'm looking for an exponential model, so I'm going to do exponential regression. Tell the calculator which list you want to use. We had our data in list 1 and list 2. So then we can calculate that, and we get A is 4 and B is 3. My R squared and R values are 1, so I know that it's a perfect formula. So I could do the same thing with this second example over here. So here we're doing something similar. We're trying to find that exponential model, but here we're working from a graph. So again, on the graph, the first thing that you want to do is think about your equation, which is y equals ab to the x. We know that it's exponential because we can tell that from the general shape of the graph. Also, it told us in the question here, but we should be able to identify that general shape. What you want to do from your graph is first identify that y-intercept. So on this graph, my y-intercept is the 0.05. So I know then that my A value is 5. Now I can work just like I did algebraically on the last question. So I'm going to go y equals 5 times b to the x. And then I'm going to come up here and I'm going to plug in this next point. So that looks like the point 110. So I'm going to go 10 equals 5 times b to the first. So b is going to be 2. So we get y equals 5 times 2 to the x power. Again, since my b value is greater than 1, I know that this is a growth situation. Over on the second example, again, here they identified the y-intercept for us, so we can just go right here and say, okay, my a value in this case is going to be 3. So I'm going to start with my equation, y equals 3 times b to the x, and then they gave me the second point, so I'm going to plug that in. So 1.49 equals 3 times b to the 4th power. So doing some algebra here, we're going to divide both sides by 3. I'm not even going to worry about evaluating that. I'm just going to leave it in that fraction form because we're going to end up putting that into our calculator anyway. So we have 1.49 over 3 equals b to the 4th power. So remember, to get rid of the 4th power, we have to take the 4th root. So I'm going to 4th root both sides here. Technically, again, this would be b is plus or minus, but we know that our b value has to be positive. So I'm going to use the positive value here. So here I can just go to my calculator. So here, just using my calculator, remember we can use that x root. So I'm going to type in the 4 and then go to my math button and use that 5 option to get the x root, and then I can type in the 1.49 divided by 3. So we get about 0.839. So we end up with b is about 0.84. My equation is going to be y equals 3 times 0.84 to the x. Just like with the table of values, I can use my calculator here to do this regression. I only need 2 points to do that. So putting my points in, x coordinates in L1, y coordinates in L2, just make sure that they are in the appropriate order. And then we're going to go stat, calc, and we're going to do exponential regression. And I get my a value of 3 and my b value of about 0.84. So looking at some word problems here, so this one, we have the population of San Jose is 782,248, and it's increasing by 2%. So remember, when they tell me the percent that I'm increasing by, I'm going to use that y equals a times b to the x. A is going to be my initial amount, and b is going to be my percent of change. So since I'm increasing, remember that's 1 plus, and then my change this into a decimal, my 2% into decimal, so my b value is going to be 1.02. So now I can write my equation. Y equals 782,248 times 1.02 to the x. Now the question asks me what will the population be in 10 years. So remember, this is time, so it goes in for x. So we're going to say y equals 782,248 times 1.02 to the 10th, which gives us about 953,556. Looking at this second example here, we have a culture of bacteria, 100, in a petri dish, and that doubles every 2 hours. So when we have this doubles situation, remember we're going to use that other equation. So y equals a times m to the x over t. So a is still my initial amount. I'm talking about doubling, so my m value is going to be 2, and it doubles every 2 hours, so my t value is also going to be 2. So we're going to start with y equals 100 times 2 to the x over 2. Again, then the question says predict how many bacteria will be in there after 9 hours. So they gave me a time value, so that's going to go in for my x. So here we're going to get y equals 100 times 2 to the 9 over 2, which gives us about 2,263.